All right, we're going to start off here with some review from our previous lesson. So we're going to switch these to exponential form. So remember, the exponential form should always be the base to some power equals some other number. And so remember that the base of the log becomes the base of the exponent. That's our b. It gets a new partner, so this time it's going to be want to be with 2. And then the 400, which was inside the log, is now over here by itself. Number 3 is the same idea, except that this is an invisible base. And so anytime we have an invisible base, remember that that is an invisible 10 here. And so when I make it into the other form, the base is going to be 10. And then to the power of the new partner, which is 0. And then that's going to equal 1. All right, now for number 5, we're going to go the other way with it. And so we're going to switch all of these to something that's going to look like a log with some base of some number equals some other number. So in number 5, I see my base is 12. That's the base of my exponent. So now that becomes the base of my log. It's going to a new partner, so the 1 is going to go inside of the log, and then it's going to equal 0. So what was in the exponent is now by itself. All right, so now we have log, and then in this case, our base is actually a b, so that's actually convenient there. And then the new partner is a, and then that's going to equal -10. All right, next step here, I'm going to evaluate the expressions, and so I'm going to say all of these equal x, and I'm going to switch them to exponential form, which remember is b to some power equals some other number. So my base here is going to be 3 to the power of x is going to equal 1 over 27. Now, since this is in the denominator, I know it's going to be a negative exponent. And so I'm going to say x equals negative, and then I know that the third power sends it from 3 into 27. Next up, number 11 here, so I'm going to say base is 4 to the power of x equals 4, and then I think it's pretty clear to see that x is 1, because that first power is going to keep it the same. All right, next up here, we're going to learn some kind of new stuff, and so what that is going to be is called expanding logarithms. And so we're going to learn 3 rules here for expanding. So the first one says if we have a log, and that could be of any base, and so I'm just going to say it's base x, and then there's multiplication inside of the log. So I'm going to call it a times b. Then we can expand that into 2 separate logs, into log base x of a plus log base x of b. And so what happens here is that the base stays the same in the 2 separate logarithms, and then the 2 things that we're multiplying are still inside of them, but now it's in 2 separate logs that are adding together. So the multiplication inside becomes addition when we split them into 2 separate logarithms. We're going to learn more later why this is kind of important and how this is useful to us, but just take my word for it now. This is useful. We are going to use it for stuff. But for now, what you got to know is the multiplication inside turns into addition of separate logs. All right, next rule is kind of a similar idea. And so it says log base x, so same idea. But now they're dividing inside of the log. And so logic would tell you that if multiplication turns into addition, that division should turn into subtraction, and that would be correct. And so kind of same idea here. We're splitting one log into 2 logs, and now these logs are subtracting instead of adding, because in the original, the inside was dividing. Last rule here is going to be if we have any log, base, whatever, doesn't matter, and then we have something inside, which I'll call a, to the power of c. And so if something has an exponent on the inside, we can take that exponent and move it out to the front. The base is going to stay the same. That a will still be there, but now that c goes into the front as a multiplier or a coefficient, if you'd like to call it that. All right, so let's use these laws here. You kind of need to know all of them. So number 13, to me, this is just rule number 3. So I'm going to take that 5 in the exponent. I'm going to move it to the front of the log. And I'm done. All right, next up, number 15. That looks like rule number 2 to me. I have division inside of a log, and so I'm going to keep the base the same and split it up, expand it into 2 different logarithms, and now those logarithms are subtracting, and that's it. Number 17 looks like rule number 1. And so that's a multiplication inside of there. So I'm going to split that up to a log base 4 of 3 and a log base 4 of 5. All right, number 19 gets a little more complicated. I'm going to say it's still kind of rule number 1 because there is just multiplying in there. So now I'm going to turn that into, actually, since there's 3 things multiplying, I'm going to turn it into 3 separate logs. So log base 3 of z plus log base 3 of x squared plus log base 3 of y to the 6th. And so notice that this second power only kept with the x because that only applied to that. The z really has a first power there. And then the y had the 6th power. And they are all adding because this is all multiplying inside of there. But I actually need to do another step here. I now need to do step 3. Since we have exponents in here, I'm going to take everything that has an exponent and move it out to the front. So that 2 is going to move out front and become log base 3 of x. And then the 6 as well will move out front. There we go. All right, last up here, it gets a little more complicated because we have kind of multiplying and dividing. And so my trick for this one, whenever I split this up, everything's going to get its own log, but everything from the numerator is going to end up with a positive log, and everything from the denominator is going to end up with a negative log. So whenever you split this up, I'm going to split this up as log base 7 of x to the 3rd. And then since these are both coming from the denominator, they're both going to go inside of negative log. So anything that's coming from the denominator goes in a negative log. Anything that comes from the numerator is going to go into a positive log. But now I need to do that step 3 again, or sorry, the rule 3, and move those exponents out to the front. So it's going to be 3 times log base 7 of x minus 3 times log base 7 of z minus 18 times log base 7 of y.